The question says, solve for x in this equation. We have minus x to be the exponent of this, and we have 243. So how do we go about this solution? So for 3 raised to power minus x equals 243. Okay, I can put this one in index form of 3. So how do I do that? So I have 243 to be 3 times 3 times 3. Okay, so 3 in 5 places give me 243. So I replace this with this and say 3 raised to power 5. So the exponent is 5. Okay, here I have 3 raised to power minus x. Now I have the same base, so I can do away with it. I have n minus x equals 5, but I want x to stand on its own, meaning I have minus 1 as a coefficient here. So I divide both sides by minus 1. So by the time I do that, I have x equals minus 5. So this is the value of 5. We want to check it. Okay, for 3 raised to power minus x equals 3 raised to power minus, for x is minus 5. So I have 3 raised to power minus times minus is plus. So 3 raised to power 5 gives me 243 divided by 0.01. Solution. When we look at this question, we have x as the index and we have a fraction where we have decimal point as the denominator. So we can resolve this by saying 10 raised to power x equals 1 over 0.001 over 1. So we can cross multiply. So we have 10 raised to power x times 0.001 equals 1 times 1. So from here we have 10 raised to power x times, so we can change this to a fraction. We have 1 over 1000, 1, 2, 3, 3 zeros, or we write this as 10 raised to power x times 1 over 10 raised to power 3, okay? Or you write it as 10 raised to power x times 10 raised to power minus 3, it's the same thing. So we have the same base, we have law of indices. When we have the same base, you are multiplying the same base, pick out one and add the exponent. So we apply it and we have 10 raised to power x plus minus 3 equals, so for 1 times 1 is 1, which is set as saying 10 raised to power 0. Okay, so here I have x plus times minus is minus 3 equals 0. So x minus 3 equals 0, which means x equals 3. Solve for divided by 2 raised to power x equals 64 raised to power x. We have to solve for x. How do we do that? Solution. So for this, I can write this as 4 raised to power 2x, which is this, equals, so for 64, I can put it in index form. So 64 in index form is set as in 2 times 2, 4, times 2, 8, times 2, 16, times 2 is 32, times 2 is 64. So I have 1, 2, 3, 4, 5, 6. So I can write this as 64 raised to power x as 2 raised to power 6 times x. Okay, the exponent law of indices. Then you have something like this. Okay, you multiply the exponents together. So here you have 2 raised to power 6 x over 1. So we can collect the line, we can cross multiply. So we have 2 raised to power x times 2 raised to power 6x equals 4 times 1. So here I have the same base. So I pick out one, I have the exponents equals to 4 raised to power 1 is 4. 4 times 1 is 4. Set aside 2 raised to power 2. Okay, so I can compare the exponents since I have equal base. X plus 6x equals 2. So x plus 6x is 7x equals 2. To determine x, I divide by 7. Okay, x is standing on its own. So I have x equals 2 over 7. The question says, evaluate 216 raised to power 4 over 3. How do we do this? Solution. Okay, so when you look at the exponents here, we have rational exponents. So how do we resolve this? So for 216 raised to power 4 over 3, it says as saying 216 raised to power 4 over 3, we have is to be the cube root of 216 raised to power 4. Okay, do not forget law of indices that says when you have a rational exponent, okay, let's say you have a over n, so it's safe as saying n roots of this, okay, you squared your result. So for cube root of 216, I have it to be 6. 6 times 6 times 6 is 216. Okay, so the cube root of 216 is 6. So I have 6 raised to the power 4. Okay, which is this. So 6 raised to the power 4 gives me 6 times 6 times 6 times 6 in 4 places. 6 times 6 is 36. 36 times 6 is 216. 216 times 6. When we work it out, we have this to be 36, this to be 9. We have this to be 12, so we have 1296. The question says, solve the equation. This is an exponential equation. How do we solve this? We have 2 raised to the power x minus 3 equals root 8 raised to the power 3x plus 2. So how do we go about this? So we have solution. Okay, so my first target is to make have equal base. So how do I do that? I have here as 2. I can put this in index of 2 as well. So how do I do that? We have root 8, okay, which is as saying 8 is power half, okay. So I can break this 8 further to be 2 raised to power 3, because 2 times 2 times 2 gives me 8, okay. So here I have 2 raised to power x minus 3, okay, equals, so for me to write root 8, I can replace it with this, okay, with 2 raised to power 3. So here I have 2 raised to power 3, okay, which takes as 8, but for the square root I have to be half, okay, 1 over 2, okay, times 3x plus 2, okay. So for this now, I can solve further. I have 2 raised to the power x minus 3 equals, so for 3 times 1, I have here 2 to be, 3 times 1 is 3, so automatically this will be 3 into 3x plus 2. Do not forget you have over 2, okay. So from here you have 2 raised to the power x minus 3 equals 2 raised to the power, we use the 3 to open up, 3 times 3x is 9x, okay, plus 3 times 2, that is 6 over 2, okay. Now we have the same base, so we can compare the exponents. We have this to be x minus 3, okay. Here we have here to be 9x plus 6 over 2, okay. So from here, because of the equal sign, we can cross multiply. So this, we multiply this, we have x minus 3 times 2 equals 1. When you multiply this with this, 9x plus 6, okay. So when you open up, 2 times x is 2x minus 2 times 3 is 6. 1 times 9x is 9x plus 1 times 6 is 6. So from here, you can collect the like times. We have 2x, we have 9x. So let's bring them together. So here is 2x, okay, minus 9x equals, I have here plus 6, okay, plus, when it comes here, you have it to be 6, okay. So for 2x minus 9x, that is minus 7x equals 6 plus 6, you have to be 12. So we can easily determine x by dividing, okay, we can easily determine x by dividing both sides by the coefficient of x, which is minus 7. So when this leave the equation, we have x equals minus 12 over 7. So solve this exponential equation. We have 3 to the power 2x minus 5 equals root 9 to the power x minus 3. How do we go about this? Solution. Okay, so for this, we have 3 to the power 2x minus 5 equals, so for root 9, instead of saying 9 is power 1 over 2, law of indices, n root of the number, instead of saying a is power 1 over n. So here I have 1 over 2, and my exponent is x minus 3. Okay, so I want to put this in the same place. Okay, to have the same base of 3. So here I have 3 raised to power 2x minus 5, which is equals, for 9, I can put it in index form, which is 3 raised to power 2. 3 times 3 is 9. Okay, so 3 raised to power 2 times, so for 1, it has multiplied this. I have x minus 3. 1 times x is x, minus 1 times 3 is 3, divided by 2. Okay, so this can easily cancel this. So here I have 3 raised to power 2x minus 5 equals 3 raised to power x minus 3. So I can compare the exponents. So I have 2x minus 5 equals x minus 3. Okay, so from here now I collect the like signs. I have 2x, okay, minus x equals minus 3 plus 5. So 2x minus x is x, minus 3 plus 5, I have that to be 2. So let us verify. So when we verify this, we have x, when x is 2, so let us work with the left hand side of the equation. So we have 3 raised to power 2x minus 5, which is 3 raised to power 2 times 2, okay, minus 5. So here we have 3 raised to power 2 times 2 is 4, 4 minus 5, we have to have 3 raised to power minus 1. Okay, for the left hand side. So let's work with the right hand side. So let us assume this is now this. Okay, so we have 3 into x minus 3. So we have 3 raised to power, when x is 2, we have 3 raised to power 2 minus 3 equals 3 raised to power minus 1. So both sides of the equation are equal. So the value of x is 2. The question says, solve the equation. Okay, we have 2 raised to power 3x minus 2 equals 8 raised to power x plus 1. Okay, so these are exponential equation. So when we look at this closely, we have the base here to be root 2, we have the base here to be 8, a whole number. So how do we resolve this? Solution. So for root 2, do not forget one of the law of indices. When I have n roots of a number, it's said as saying a is power 1 over n. So when we can write this root 2, okay, as 2 is power 1 over 2. So when I put this in this form, so I have here 2 is power half, okay, times, here I have 3x minus 2 equals, for 8 I have 2 is power 3 into x plus 1, okay. So now I have the same base, so I can compare the exponents. So I have here 1 over 2 into 3x minus 2 equals, so I have here 3 into x plus 1. Okay, so the next step, we can open up the brackets with what we have here. So you have 1 times 3x to be 3x, okay, minus 1 times 2 to be 2, divided by 2, okay, equals 3 times x, that is 3x. 3 times 1, we have that to be 3. Okay, so from here, because we have equal sign, we can now cross multiply. This will multiply this. So here we have 3x minus 2 times 1 equals 3x plus 3 times 2. Okay, so when you open up, you have 1 times 3x to be 3x. Minus 1 times 2 to be 2. 2 times 3x is 6x plus 2 times 3, that is 6. So the next thing we do, we collect the like times. So here we have 3x. Okay, this is coming here. We have it to be minus 6x. Here we have 6. This 2 is coming here. We have it as plus 2. Okay, so 3x minus 6x, that gives us minus 3x equals 6 plus 2, that is 8. So from here now, to find x, we can divide both sides by the coefficient of x, which is minus 3. So minus 3, minus 3. So we cancel out this. We have x equals minus 8 over 3. Solve this exponential equation. I can write a fraction. How do I do that? I go a straight line, the point turns to 1, the number turns to 0. So I have 5 over 10 or 1 over 2. So I can replace this with 1 over 2. So I have here 1 over 2 raised to power x minus 2 equals, so for root 2, okay, I can write this as 2 raised to power half, okay, law of indices, n roots of the number is written as a raised to power 1 over n. Okay, so when I write this in this form, I have it here, I have it in this way. So for root 2, I can write it as 2 raised to power 1 over 2 times the exponent I'm having, that is 3x plus 1. Okay, but for 1 over 2, I can write 1 over 2 as 1 over 2 raised to power 1 or 2 raised to power minus 1. Law of indices, when you have something like this, okay, it's just like saying a raised to power minus n. So when you apply this to this, for 1 over 2, I can write it as 2 raised to power minus 1, okay. We have x minus 2 equals, I have here my 2, when you multiply 1 with this, you have 3x plus 1 over 2, okay. So for this, don't forget the exponent law. When I have something like this, a raised to power n into n, I can say a raised to power, you multiply this exponent, n times n, that is nn, okay. So when you apply this to this, you have 2 raised to power minus 1 times x is minus x, minus 1 times minus 2, that is plus 2, equals 2 raised to power 3x plus 1 over 2. Now you have the same base, take it out, compare the exponents, you have a minus x plus 2 equals 3x plus 1 over 2. Okay, so from here we have equal sign, you can cross multiply, so you have a 2 into minus x plus 2 equals 1 into 3x plus 1. Okay, so when you open up with what you have here, you have 2 times minus x to be minus 2x plus 2 times 2, that is 4, 1 times 3x is 3x, plus 1 times 1 is 1. So at this point, you can collect the like signs. So here you have minus 2x, okay, minus 3x equals 1 minus 4. So minus 2x minus 3x gives us minus 5x equals, when you subtract this, you have here minus 3. So to determine x, we divide both sides by minus 5, which is the coefficient of x. This can go, this will go. We have this, we divide. So we have here x equals 3 over 5. The question says, solve this exponential equation. We have 3 is power 2x minus 5 equals 9 is power x minus 3. How do we go about this? Solution. Okay, so for this, we have 3 is power 2x minus 5 equals, so for root 9, instead of saying 9 is power 1 over 2, law of indices, n roots of the number, instead of saying a raised to power 1 over n. So here I have 1 over 2 and my exponent is x minus 3. Okay, so I want to put this in the same base, okay, to have the same base of 3. So here I have 3 raised to power 2x minus 5, which is it equals, for 9 I can put it in index form, which is 3 raised to power 2. 3 times 3 is 9. Okay, so 3 raised to power 2 times, so for 1, it has multiplied this, I have x minus 3, 1 times x is x, minus 1 times 3 is 3, divided by 2, okay, so this can easily cancel this. So here I have 3 raised to power 2x minus 5 equals 3 raised to power x minus 3. So I can compare the exponents. So I have 2x minus 5 equals x minus 3. Okay, so from here now I collect the like signs. I have 2x, okay, minus x equals minus 3 plus 5. So 2x minus x is x, minus 3 plus 5, I have that to be 2. So let us verify. So when we verify this, we have x, when x is 2, so let us work with the left hand side of the equation. So we have 3 raised to power 2x minus 5, which is 3 raised to the power 2 times 2, okay, minus 5. So here we have 3 raised to the power 2 times 2 is 4, 4 minus 5, we have to do that 3 raised to the power minus 1, okay, for the left hand side. So let's work with the right hand side. So let us assume this is now this, okay. So we have 3 into x minus 3. So we have 3 raised to the power, when x is 2, we have 3 raised to the power 2 minus 3 equals 3 raised to the power minus 1. So both sides of the equation are equal. So the value of x is 2.